Okay. What we're going to do today, guys, is we're going to sort of work backwards. I'm going to give you a couple of points that pass through a parabola, and we're going to take those points and turn them and figure out what rule made that parabola, basically. So what quadratic caused that parabola to exist? We're going to do it two ways. The first way is the funner way, which is essentially guess and check. Much funner. The second way we're going to do it is algebraically. I will give you the heads up. This is something you will need to do for your assignment. So the reason we're doing this today is, to give you good practice on that. Well, we don't have class tomorrow, but I think I'll give it to you Friday. Yes. Because then it would just be due on the Monday in week 8 instead of the Friday in week 8. You wouldn't get any extra time. Okay. Do we all have our points in? Okay, what I want you to do is write this. Y equals ax squared plus bx plus c. Shift 6 will give you the up arrow, which then puts it up there. And then underneath where it says add slider ABC, I want you to click all.
Plus
C. Now, this is your job for the next couple of minutes, guys. I want you to try and find a line. I want you to play with those sliders so that you can make the quadratic go through all three points.
Y equals ax squared plus 6.
Plus bx plus c. Yep, and add sliders. And I want you to play with this.
Yeah. So good. Can you make that red door?
Sure can.
Oh,
Something went wrong.
what is it? The order. Yeah, so go to the blue.
Okay. You can't get it through the blue one. I'll give you a hint, guys. If I only gave you 2 points, there's only one sorry, if I gave you 2 points, there's like infinite possible lines that go through it. But if I've given you 3, there's no way to get around that. Does anyone, how many unknowns are in that little formula there? Y equals ax squared plus bx plus c3. That's why we need 3 points to get the line exact. There's only one quadratic that goes through each of those 3 points. Only one. Anyone feel like they're close? Yeah. Not yet? Close. I'll give you another minute or two, guys. You have the right idea. Please. That is sad. I'll show you. If you zoom in, you'll see that all of those points wrong. Would you guys like a hint? I'm going to give you a hint. Of the 3 of those points, the easiest one to guarantee is on the line is your C value. Because your C value is your what? Y-intercept. So if you change C, and if you look at mine up there, C, so it goes through 0, 0. See now, no matter where I move it, it always passes through that point. So I basically managed to lock down one of my points. No matter what I do to A and B, as long as C's in the right spot, it'll always have one of them exactly on it. Now, another thing I want to just ask, guys, is this line going to be a smiley or a frowny? Smiley. So you know that A has to be positive. So that gives you some options there. You got it?
Yeah, dude.
Just look.
Almost.
Not quite. Not quite.
You got it, President.
You got it? What's your A value? Not quite.
Oh, this is sorry. Make it like the settings in it. Why don't you got that?
1 more minute, guys, and we'll go through it together. Yo.
Did you take my shit and eat part of it? No.
Amber, did you just get it?
That is yelled out.
Emma, just tell us. Goodness gracious,
I
what?
just yelled it out.
Alright.
You opened your hands, you can't.
Alright.
I'll show you how
I'll show you the way. I also cheated because I created the line and then got the points off it. But I will show you the way that I would approach this, guys. Like I said, step one, you lock down your C value. Step 2, A and B, you can't really lock them down. All you can do is try and do your best guess. Can you see that when I move my B value, that changes where the turning point is fairly significantly, right? Where should the B, where do you think the turning point would be?
That's
You think the turning point is there? It has to be either at the level of that green dot or lower. Do you see why it has to be either at that level or lower? Because either the green is the lowest it goes, or the function goes down lower and then meets back up with the green. You can see that by moving my B, it must be lower, so I have to keep moving my B over. Looking at this though, can you see that my turning point might be somewhere around there, but it's not hitting these other 2 points. So that's when I play around with the A value. So if I make it bigger, that ain't helping. So I might make it small. If I make it that small, I'm going to have to change B again. Well, that's close. Oh, I got 2 of them on the line, but not quite. Oh, there we go. The last 2 is very much playing around. What did I do? So I knew that my turning point must be somewhere around here on my graph. So I just kept playing with A and B values until I got it around there and managed to get all 3 of them in.
So what's your A equal to? Negative what?
A is positive 0.5.
Yeah, what's your B?
Negative 3. Okay. Now, yeah, this is... You can zoom in. On the A value or whatever. If you click on it, you can give it a specific value. The next set of points, guys. If you want to delete you got there, or just turn them off or whatever, the next points I want you to find 0,6, 2,2, and negative 2, negative 6. And I'm going to start a timer on this one. See how quickly someone can get it. Where's my timer at? Stopwatch. Okay, your time starts now.
So what is it? Y equals AX, where
It's like VX plus C. You can reuse your line from before, you just got to replay with it.
Yeah. I put the change one. Oh my god, 8 was the next. I why this? Here. What about the Senate of the state? Being involved. Yeah. Oh,
That's no doubt. Yeah.
yeah, but I'm still at this. So I got it. I got it. Right? I'm so close.
Got on 3 right?
Yeah. I got a 2.
Got a 2.
That I don't think is quite correct.
Oh my god, please.
They should all be whole numbers. I'll give you a hint.
Well, it's like 0.1 off. Yes. Yeah, got it. Got it.
Got it.
Is that right?
So what you did? So who you
Mine was 1.2. Yeah, I think.
It says that you want 226. And you got 226.
Yes.
Okay. So guys, that took like under 2 minutes for the first couple of people to get that one, which was pretty impressive. For those of you who haven't quite got there yet, if you have your eyes up here, once again, guys, straight away we can lock down our C value if we can, because can you see we've got a y-intercept of 6, so we want to have our C value at 6. Now straight away, oh, it's gone through 2 points already, but I know, looking at where those points are, this has got to be a frowny. So my A value should be negative. I know, I'm going to go for -1 at the minute. Once again, my turning point will either be at the y-intercept or somewhere around it. So I'm just going to play with the B, get them a bit, I think maybe something like that, but if I play with this a little bit more. There we go. All 3. Questions, comments, concerns, conundrums?
Yeah, that's what I'm
Yep, I got another one locked and loaded for yous.
Right. Wait, he said, shoot. Point. Oh, yes. I don't. Microphone.
Sounds about. Wait.
Oh, this is C. Microphone.
Okay. This one, guys, I will give you a hint. The A, B, and C values are either whole numbers or they're to 1 decimal place. So it could be like 5.3 or -2.4, but it's to 1 decimal place. So this one's obviously a lot trickier.
So these just.
Yeah. Well, I guess it's like I made a function and then just picked random points on it.
Wait, what?
Okay, let me.
So the top one's 0 point.
0,3.9, sorry. You got me a comma.
Add it now. Even on.
Add what?
Interesting.
You'll see that line straight up because it goes through the point zero. C should be -3, but you are very close. I think there is a way. So might actually be right. Let me check.
Well, I got an angry pretty.
So Mia beat your Zols.
Then is it 1, -2, 1,
Is
1?
it like close? You just
What did you say A was?
But what's the difference then?
Yeah.
That's a one. Where's that dog?
Oh, that's negative. Sorry, guys. This one here is -5. Did look a little bit like a 3.
Is this near correct?
Ian, what is it? What's that?
It's not only near correct, it is correct.
So
Yeah.
pretty good. That's right.
What are my 3 points?
What is it?
3.1.
Do you introduce an assistant?
Do we get this?
Possibly.
What's going on?
Yeah, this is you get me.
So I got it all by myself.
Good work.
What's it?
Because we had a few people get it, guys. If you cast your eyes up here, as always, I'm gonna lock in my C value first. C equals -3.9. 3.9. Clearly, A should be positive, so I'm gonna flick A back up into the positive. And then I just play with B until the turning point looks about right. Where would the turning point likely be? Lower? So somewhere over here, I would assume. So now I'm just going to keep playing with A and B. Well, that's 2 of them.
1, 2.
Sometimes the sliders are a pain in the butt to use. There we go. Makes sense, guys? Pretty... We're literally just guess and checking in speed mode, essentially, with the way we're doing this. Is there another? There's some we're going to practice later. But what I want to do with you now, guys, I want to do the same thing, but without the guess and check. It's not. I mean, depending on your frame of reference. I'm going to do this in the OneNote, guys, just so that there's a record of it. So I'm going to go over here. Okay. Our first one. So So this is our first one, guys. You need to have your eyes up on the TV. You can close your laptops. We won't be on them. Yeah, for the rest of the lesson. Sure. Could someone please grab the lights for me?
Hey,
Tyler, you're up. Oh, it's not in there. Okay. So, guys, is that zoomed in enough to see? Okay. We want to algebraically now find the quadratic that passes through those 3 points. To do this, we're going to do the exact same thing, but we're going to do it mathematically this time instead of visually. So when we did it last time, what was the first point we locked in? C. The reason C is easy to lock in is because it is basically where x equals 0. And as long as you have a 0, you're going to be having an easy time. For us, what we're going to do is we're going to solve this one using any 0 points that we can. So what does every quadratic look like ever? Ax squared plus bx plus c. That's every quadratic ever. Now, which of those 3 points is going to be easiest for us to sub in? Which of the 3 points that I've been given?
Sure, point 0.
Yeah, 0, 0. Because when I sub in 0, 0 to my rule, a bunch of stuff is going to disappear. And that's what I want. So I'm going to sub in 0, 0. And I'm just going to do a note. Always sub in points with a 0 first. So that'll give me, instead of y, what am I subbing in? 0. Instead of x, what am I subbing in? So on the left-hand side, we have 0. A times 0 squared is 0. And then b times 0 is also 0, and then c. So I know that c equals 0. So therefore my rule is y equals ax squared plus bx plus 0. That's my rule. How many unknowns are left? 2. Luckily, we have 2 other points to sub in to help us solve. Now, we're going to have to sub in both points. So I'm going to, over here, I'm going to sub in -2, 8. And over here, I'm going to sub in 4, -4. So on the left, my y value is 8, is equal to a times -2 squared plus b times -2, and then it's plus 0, so I'm not even going to write the plus 0. Who has the time for that? The 8. Yeah, so that became the y, and then all the x's become. Because that coordinate point is just an x and a y value that we know that the function passes through. So normally, we're kind of coming at this backwards. Normally, we know the rule and we sub in the x values. This time, we don't know the rule, but we do have x and y values that it passes through. So we're subbing in the x and y values that we know exist on the line until we find out what those a, b, and c values are. I was going to write plus 0, actually. So let's evaluate this. 8 equals -2... Sorry. What's negative 2 squared? Positive 4. So 8 equals 4a minus 2b. So there's not much we can do with that now. So let's pop on over to this other sub in. This time I'm subbing in 4, negative 4. So negative 4 equals a times 4 squared plus b times 4 plus 0, which gives us negative 4 equals 16a. Plus 4b. Okay, so we have two equations that have a's and b's in it now. What could we do? Sorry? We can, adding an equation is difficult. There are ways to do it. Basically, we have to solve them simultaneously. Do you guys remember doing simultaneous equations in year 10? Sort of, a bit. This is the way I would solve it. Looking at those two equations, we have left-hand equation, right-hand equation. What we basically want to do is get either an a or a b by itself, and then we're going to sub that into the other rule. Of the left-hand and right-hand equations, which one has a value that looks like it'll be easy to sub into the others? Or like easy to get by itself? I'm trying to figure out which way things are, because I'm looking at a different perspective. So left one or right one?
Left.
Left?
Right.
Well, both of them have one that would be easy to get by itself. I'm looking at this 2b, and I reckon it'll be easy to get b by itself. So I'm going to make a note. Get b as subject of formula. So we have 8 equals 4a minus 2b. What do I mean, guys, when I say make it the subject of the formula? Yeah, I want to have b equals something. I won't be necessarily solving for it because I'm not going to get a numerical answer. There's still going to be an a in there, but I want b to be by itself. So if I want to get b by itself, I got to get rid of that 4a. How am I going to get rid of the 4a? Take 4a from both sides, that's it. So that gives me minus 2b equals. This is the biggest mistake people make in these kind of things, guys. They forget the minus attached to the b. Equals 8 minus 4a. Is b the subject of the formula? Not yet. Still got that negative 2. So I'm going to divide by negative 2. Divide by negative 2. So that gives me b equals... What's 8 divided by negative 2? Negative 4. What's negative 4 divided by negative 2?
Positive 2.
Sorry?
Positive 2.
Plus 2. So we end up with b equals negative 4 plus 2a. I'm going to call this equation 1. Yeah, because it wasn't doing anything for us. I'm going to call that equation 1. I'm going to call this equation 2. I'm going to keep going down the left-hand side here. I'm going to say sub equation 1 into equation 2. So anywhere there's a b in equation 2, I'm going to replace that b with minus 4 plus 2a. This might make a little more sense why I put my subbings in brackets, just so it makes it really clear what's going where. So that gives me negative 4 equals 16a plus 4. And then instead of that b in equation 2, I'm replacing that with equation 1. So minus 4 plus 2a. This is normally the spot where I expect people to be like, whoa, 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 what are we doing? Are we feeling all right with this, guys? Zoe's all over it. Sorry? Yep.
And you know when to sub it, where to sub it in.
Do you mean where to sub it in? Well, I know that I know what B is equal to. So anywhere in the other rule that B is, I can replace that B with what I found it to be equal to. If I could have also rearranged for A if I wanted to. The only reason I did B is because B's got a smaller number in front of it, and it would be easier to divide stuff by 2 than dividing stuff by 4. So let's expand out our brackets, guys. We got -4 equals 16a. 4 times -4 is -16. 4 times 2a is plus 8a. What would I do from here? Get a on its own. So I'm going to get all the non-a stuff to the left, all the a stuff to the right. So to get rid of this non-a -16, what am I going to do? Plus 16. Plus 16. Which gives us, on the left-hand side, -4 plus 16 is 12. What's 16a plus 8a? 24a. To get a by itself, divide both by 24. Divide by 24. That looks like 2a. That should be a 4. My bad. A equals 0.5. Which, if we put our rule together now, we know therefore our rule is y equals 0.5 x squared plus bx plus 0. There's one unknown left. Y.
B.
Yes. How we got x? We haven't solved x. There's a few ways you could go from here, guys. The easiest way, I think, to solve for a, if we look at equation 1, guys, sorry, to solve for b, see equation 1 already has b by itself. The only thing unknown in that equation is a, but do we know a now? Yeah, so sub a equals 0.5 into equation 1. So equation 1 was b equals -4 plus 2a. So b equals -4 plus 2 times 0.5. b equals 3. Which gives us my rule, y equals 0.5x squared plus 3x plus 0. Now, is that the rule we came up with when we solved this visually?
So, wait.
So originally we started this whole adventure with every quadratic looks like that. And because we solved for a, we can say, well, instead of saying ax squared, we can now say 0.5x squared. Questions, comments, concerns? No? Here's the question, guys. Do you think you'd be able to follow the same process for the second law? I'm going to give you guys 10 minutes. I want you to have a go at that second set.